Bismillahirrahmanirrahim. Welcome to Al Munir High School e-learning system, class 9. This is your chemistry lecture. Today we are going to discuss our unit number 5. This is your chemistry book title page for class 9. In unit number 5, we are going to discuss about the physical states of matter. Yes, all of us know about the different states of matter. Matter can be in solid state, in liquid state, or in gaseous state. So here we have the introduction. We all know that matter exists in three physical states: gas, liquid, and solid. The simplest form of matter is the gaseous state. Liquids are less common and most of the matter exists as solid state. Matter in gaseous state do not have definite shape and volume. Therefore, gases occupy all the available space. Their intermolecular forces are very weak. Pressure is a significant property of gases. The effect of pressure and temperature on volume of a gas has been studied quite extensively in this chapter. So it is all about the gaseous state of the matter. The liquid state has strong intermolecular forces. They have definite volume but no definite shape. It retains the shape of the container in which it is kept. Students, we all know about all these things of different states of matter and what is matter, what are the different states of matter, what are the properties of solid, liquid, and gas state of matter in our previous classes. Liquids evaporate and their vapors exert pressure. When vapor pressure of a liquid becomes equal to the external pressure, it boils. Liquids are less mobile than the gases. And the solid state has definite shape and volume. They are rigid and denser than liquids and gases, and they have different forms. First of all, we will look at the gaseous state, the typical properties of the gases. Number one is diffusion. Gases can diffuse very rapidly. What is diffusion? Diffusion is defined as spontaneous mixing up of molecules by random motion and collision to form a homogeneous mixture. So what is diffusion? Diffusion को हम कैसे define करते हैं कि on the spot spontaneous mixing हो molecules की random motion या उनके आपस में टकराने की वजह से और वो फॉर्म करें homogeneous mixture को, same type of a mixture को, that will be called the diffusion, and it takes place in gaseous state. Rate of diffusion depends upon the molecular mass of the gases. Lighter gases diffuse rapidly than heavier ones. Here we have the example. Hydrogen diffuses 4 times faster than oxygen gas. So hydrogen is lighter gas. Next is effusion. What is effusion? It is escaping of gas molecules through a tiny hole into a space with lesser pressure. So effusion is a process in which gas molecules escape from a tiny hole with less pressure. For example, when a tire gets punctured, air effuses out. Effusion depends upon the molecular mass. Lighter gases effuse faster than the heavier gases. जो लाइट वेट गैसेज होती हैं, लाइटर गैसेज होती हैं, वो ज़्यादा फास्ट इफ्यूज होती हैं. Next, pressure. We all know about the pressure. Gas molecules are always in continuous state of motion. Hence, when molecules strike, टकराते हैं जब गैस के molecules with the walls of the container or any other surface, they exert pressure. तो वो किसी भी कंटेनर या सिलेंडर के अंदर जब फिल किया जाता है गैस को, तो उसकी वॉल से जाके टकराती है और प्रेशर एक्सर्ट्स करती है उनके वॉल के साथ. दिस टर्म इज कॉल्ड द प्रेशर. प्रेशर इज डिफाइंड एज द फोर्स F exerted per unit area A. So pressure is force per unit area. The SI unit of force is Newton and area is meter square. So what will be the unit for the pressure? It will be Newton meter square, and it is also called as Pascal. 1 Pascal is equal to 1 Newton meter square. In barometer is a device or instrument that is used to measure the atmospheric pressure. Next, we have the standard atmospheric pressure. It is the pressure exerted by the atmosphere at the sea level. We defined at standard atmospheric pressure as pressure exerted by a mercury column 760 millimeter height at sea level. So we always use mercury column, mercury element to check as a standard to measure the standard atmospheric pressure. It is sufficient pressure to support a column of mercury 160 millimeter in height at sea level. So scientists used mercury column of 760 millimeter height at sea level to measure the standard atmospheric pressure. 1 atm is equal to 160 millimeter of mercury, which is equal to 1760 torr. So 1 millimeter of mercury is equal to 1 torr, and its value is 101325 newton meter square, which is equal to 101325 pascals. So you have to learn and remember all these measurement units which is given by different scientists. Next property of gases are compressibility. Gases are highly compressible due to empty spaces between their molecules. When gases are compressed, the molecules of gases come closer to one another and occupy less volume as compared to the volume in uncompressed state. So gases have the ability to compress because of their empty spaces between their molecules. Next property is mobility. Gas molecules are always in state of continuous motion. They can move from one place to another because gas molecules possess very high kinetic energy. Because of high kinetic energy, gas molecules remain always in the state of motion. They move through empty spaces that are available for the molecules to move freely. This mobility or random motion results in mixing up of gas molecules to produce homogeneous mixture. Next property is about the density of gases. Yes, gases have low density than liquid and solids. Why it is so? It is due to the light mass and more volume occupied by the gas molecules. So this is the reason that gases have low density. Gas density is expressed in grams per decimeter cube, whereas liquid and solid densities are expressed in grams per centimeter cube. So this is very important. Please underline it. We measure or express gas density in grams per decimeter cube, and we express liquid and solid densities in grams per centimeter cube. Liquid and solids are 1000 times denser than gases. The density of gases increases by cooling because of their volume decrease. For example, at normal atmospheric pressure, the density of oxygen gas is 1.4 grams decimeter cube at 20 degrees centigrade. But at 0 degrees centigrade, it will reduce it will be 1.5 grams decimeter cube. So the density of gases increase. Look at this increase by cooling. Next we have test yourself questions. Look at the answers of this mini exercise. Look at the first question. Why the rate of diffusion of gases is rapid than that of liquids? Answer is the rate of diffusion of gases is more than that of liquid because more empty spaces are present between their molecules as compared to the liquid. Number two, why the gases are compressible? Gases are highly compressible due to empty spaces between them. Number three, what do you mean by Pascal? How many pascals are equal to 1 atm? Yes, I just told you the pressure equal to 1 Newton per square meter is called Pascal, and 1 atm is equal to 101325 pascals. Whether why the density of a gas decreases on cooling? The gas molecules The gas molecules are far apart to each other due to very weak intermolecular forces. Among them, gases occupy more spaces at normal condition as compared to the liquid. That is why a smaller unit of volume measured is used for liquids. Why is the density of gas measured in grams decimeter cube while that of a liquid in grams centimeter cube? The answer is the gas molecules are far apart to each other, and that is why a smaller unit of volume measured is used for the liquids. Now convert the following. Yes, we can easily convert it. So 70 centimeter of mercury to atm by 1 centimeter of mercury is equal to 1 over 760. By multiplying it 70, we will get the answer, which is 0.0921 atm. Next, 3.5 atm to torr. So answer will be 2660 torr. And in the last part C, 1.5 atm to Pascal, answer will be 151987.5 Pascals. So student, next our topic is about the laws related to the gases. Yes, it is very important. First of all, look at the statement of the Boyle's law. According to this law, the volume of a given mass of a gas decreases with the increase in pressure, and vice versa. Mathematically, it can be written as volume is directly proportional to 1 over pressure, or V is directly proportional to 1 over P, where K is our constant. In 1662, Robert Boyle studied the relationship between the volume and pressure of a gas at constant temperature. So here temperature is constant. If the given mass of gas decreases, its pressure increases. So he observed that volume of a given mass of gas is inversely proportional to its pressure provided the temperature remains constant. So we can show these amounts with the help of P1 V1 is equal to K, then P2 V2 is equal to K. The value of K is same for the same amount of a given gas. So therefore Boyle's law can be stated as the product of pressure and volume of a fixed mass of a gas is constant at constant temperature. So here P1 is initial pressure, V1 is initial volume, P2 is final pressure, and V2 is final volume. As both equations have same constant, therefore their variables are also equal. So P1 V1 is equal to P2 V2. Next we have the experiment for the verification of Boyle's law. Look at this experiment. This experiment shows the relationship between volume and pressure by the following series of steps. Let us take some mass of a gas in a cylinder having a movable piston and observe the effect of increase of pressure on its volume. So here we have the cylinders, and here we have the pistons on the top of the cylinders. When the pressure of 2 atm is applied, the volume of gas reads as 1 decimeter cube. So here we have 2 atm and the volume will be 1 decimeter cube at 2 atm. When pressure is increased equivalent to 4 atm, so here we have more pressure, we exerted more pressure, which is 4 atm. Now look at its volume is decreasing with the increase in the pressure. The volume of the gas reduces to 0.5 decimeter cube. So this experiment shows that by exerting more pressure, the volume will if the pressure increase, the volume decrease. If we look at this diagram from right to left, look here, when the volume increase, the pressure will decrease. We can calculate the product of volume and pressure from this experiment. The product of all these experiments is constant at 2 atm into 1 decimeter cube. The answer will be 2 atm decimeter cube. So it is proved that for this from this experiment, the product of all these experiments is constant, which is 2 atm decimeter cube. It proves the Boyle's law. Now look at test yourself questions of 5.2. Look at the first question. Is the Boyle's law applicable to liquids? No. Number 2, is the Boyle's law valid at very high temperature? No, the Boyle's law is not valid applicable at high temperature. What will happen if the pressure on a sample of gas is raised 3 times and its temperature is kept constant? If the pressure on a sample of gas is raised 3 times at constant temperature, the volume will also decrease 3 times to its original. Here we have the interesting fact. In which units blood pressure is measured? Blood pressure is measured using a pressure gauge. So here we have the pressure gauge. It may be mercury nanometer or some other device. Blood pressure is reported by two values such as 160 by 80, which is a normal blood pressure. So normal blood pressure is 120 by 80. The first measurement shows the maximum pressure when the heart is pumping. It is called the systolic pressure. When the heart is in rest position, pressure decreases, and it is the second value, which is the diastolic. Both of these pressures are measured in torr units. What is hypertension? Hypertension is because of high blood pressure due to tension and worries in our daily life. Look at this example, a gas with volume 350 centimeter cube. So first volume is 350 centimeter cube. The first pressure is 650. P1 is 650 millimeter of mercury. P2 we have to is also given, which is 325 millimeter of mercury. We have to find out the volume, final volume, or V2 by using the equation of Boyle's law. We compare it, take the V2 on the left hand side because we have to find it, and other values on the right hand side. By putting the values, we will get the answer of or value of V2. Thus the volume of gas is doubled by reducing its pressure to half. The next example is the same. We have first volume, which is 785 centimeter cube. P1 is 600 millimeter of Hg. Here V2 is given, which is 350 centimeter cube. We have to find out the P2, the final pressure, by using the Boyle's equation. Now take the P2 on the left hand side because we have to find out the value of P2. By putting the values, we will get the answer P2. Thus it shows pressure is increased by decreasing the volume. Next is about the absolute temperature scale. Lord Kelvin introduced, it is the name of the scientist, introduced absolute temperature scale or Kelvin scale. So this scale is called Celsius scale, and this is the Kelvin scale. This scale of temperature starts from 0 to minus 273 degrees centigrade, which is given the name of absolute zero. It is the temperature at which an ideal gas would have zero volume. As both scales have equal degree range, therefore when 0K equal to minus 273 degrees centigrade, then 273 Kelvin is equal to 0 degrees centigrade. So both scales have the values which is opposite to each other. Conversion of Kelvin temperature to Celsius and vice versa can be carried out easily. Next we have the Charles law. Yes, the relationship between volume and temperature. So Charles in its law observed the relationship between volume and temperature, keeping the pressure constant. So in this law, the pressure will remain constant, and with the slightly increase or decrease in volume, the temperature will change, or with the increase or decrease in temperature, the volume will change. French scientist J. Charles in 1787 presented this law that states that the volume of a given mass of a gas is directly proportional to the absolute temperature if the pressure is kept constant. So this is the main statement of Charles law, and it is about the volume and temperature, where our pressure is constant. The volume of a given mass of gas is directly proportional to absolute temperature, so we can represent it as, and here temperature pressure is kept constant. So K is our constant, K is proportionality constant. If temperature of gas is increased, its volume also increase. When temperature is changed from T1 to T2, the volume change from V1 to V2. The mathematically form of Charles law is this: V1 over T1 and V2 over T2. Next we have the experimental verification of Charles law. Let us take a certain amount of gas enclosed in a cylinder. So here we have the cylinder where we have certain amount of gas enclosed in it, and with a movable piston. So this is a movable piston. If the initial volume of the gas V1 is 500 centimeter cube, so here temperature is 25 degrees and volume is 50 centimeter cube at initial temperature T1. is 25 degrees. On heating the cylinder, if we will heat it up to 100 degrees centigrade, its new volume will be 62.5 centimeter cube, and new temperature is 100 degrees centigrade. So here the Charles law has been proved that increase in temperature increases the volume, that can be observed as elaborated below in the figure 5.2. So who was J. Charles? He was a French inventor or scientist, mathematician also. So remainder, always convert temperature scale from degrees Celsius to Kelvin scale while solving problems. So here while solving problems, you must remember or learn this value of K. K is always equal to 273 plus degrees centigrade. Next we have example. Here we have according to the Charles law, we have volume 1 250 centimeter cube, and temperature which is minus 30 degrees centigrade. So we can convert it by using this formula into Kelvin, and V2 is 700 degrees centigrade. We have to find out the final temperature by using the equation. Keep the unknown value on the left hand side. By putting the values, we will get the temperature which is 680.4 Kelvin. Thus expansion is caused due to increasing temperature. Next, example number 5.4, a sample of hydrogen gas occupies a volume. So first volume is 160 centimeter cube. Temperature is given in Celsius, 30 degrees centigrade. We can easily convert it. We know that 0 degree centigrade is equal to 273 Kelvin. So temperature 2 is also given which is 100 degrees centigrade. By using the above table, we know the value 373 kelvins. We have to find out the final volume. So we will keep the V2 on the left hand side because of the unknown. Because we have to find the value of V2. By putting the values, we will get the volume of the volume, or we can say that the final volume. Thus, volume of a gas has increased by raising the temperature. Remember, degree sign is used with Celsius scale, not with Kelvin scale. हम डिग्री का साइन या सिंबल यूज नहीं करते केल्विन के साथ. So here we have test yourself 5.3. Which parameters are kept? Which variables are kept constant in Charles law? Pressure is kept constant. Why volume of a gas decreases with increase of pressure? The volume of the given mass of the gas is inversely proportional to its pressure provided the temperature constant. So by the increase in pressure, the molecules of gas compress and come closer to each other. What is absolute zero? It is the temperature at which an ideal gas would have zero volume. Does Kelvin scale show a negative temperature? Yes. At 0 degree centigrade, the Kelvin scale shows the negative temperature or value. Number 5, when a gas is allowed to expand, what will be its effect on the temperature? When a gas is allowed to expand, it will cause the cooling effect. Can you cool a gas by increasing its volume? Yes, by sudden increases the volume of a gas, it gives the cooling effect. In which units body temperature is measured? Body temperature is measured in Fahrenheit scales. Normal body temperature is 98.6 degree Fahrenheit. It is equivalent to 37 degree centigrade. This temperature is close to average normal atmospheric temperature. In winter, atmospheric temperature falls lower than that of your body temperature. According to principle of heat flows out from our body and we feel cold. Next, we have physical states of matter and their role of intermolecular forces. We know about the nature of the molecules of gas, liquid and solid. As we know that matter exists in 3 physical states: gas, liquid and solid. In gaseous state, the molecules are far apart from each other, so their intermolecular forces are weak. But in liquid and solid, intermolecular forces play important role on their properties. In liquid state, molecules are much closer than that of gases as compared to the gases. As a result, liquid molecules develop stronger intermolecular forces than gaseous state. Compounds having stronger intermolecular forces have higher boiling points as shown in figure 5.3. So this figure 5.3 shows the three states of matter showing intermolecular forces. The intermolecular forces so dominant in solid state that the molecules look motionless. They range in a regular pattern and they are denser than molecules of liquids. Next we have the liquid state. Liquid have definite volume but their shape is not definite. A liquid attains shape of the container in which it is put. A few typical properties are discussed later. Thank you. Allah Hafiz.